Now we'll use Excel to compute regression. A simple regression has the formula y equals a plus bx. And in that, a is the intercept and b is the slope. So let's see which functions let us look at the slope and intercept. So we come up to our function, look under statistical, and come down here. There's an intercept. And we're going to do arrays of known y's and known x's. So in this particular case, we want to look at, in regression, the x variable is used to predict the y variable. Now, in correlation, we're usually just talking about the association of two variables. It doesn't matter if you're looking to see whether vitreous chamber depth correlates with anterior chamber depth, or anterior chamber depth correlates with vitreal chamber depth. But in this case, we want to know, do the years before and after the onset of myopia, what's their relationship to refractive error? So known y's are going to be this refractive error, Control Shift up arrow allows us to get through all of them. And known x's are going to be this variable called init years. Now, init years refers to time before and after the onset of myopia. So we have 0 is the onset, the year that the person first met the clinical diagnosis of myopia. This is a year before, a 1 is a year after, and so forth. And so the intercept in this particular model is -1. Now let's look at the slope. And so we look at our function, find statistical. Well, maybe it will. And come up with slope. And again, the known y's are going to be refractive error. And the known x's are represents the internet, the years around myopia onset. Okay, so our formula is refractive error equals minus 1.52 plus a minus 0.579 times the years, times years. And so we could actually use this formula in predicting the values for each of these cases. So we're going to say equals the intercept, hit F4 to put dollar signs around that, plus the slope, dollar signs, times init years. And while we don't have to really do anything with the function F4 here, we could say we want to fix it so that we can look at other variables and fix it at column D. So we predict for this first person, they have, and they're 2 years into their myopia. Their actual refractive error was -3. We predict them at -2.6. And then we can copy this. Let's just drag this guy down. And so now we have created predicted values for everybody. One thing that's very useful here is to also look at the residuals. So these are predicted values. These are going to be residuals. A residual is the difference between the actual refractive error minus the predicted. So it's that difference. Let's copy this guy. Copy, Control arrow down, over, Control Shift arrow up, Control V to paste. Now we have the residuals. Let's sum the residuals. Equals sum residuals. The sum is 0. That's why this is called the least squares model, because if you sum all the residuals, it's the least square residual on each side is the sum of those equals 0. So this is the best fitting line. That's why it's the best fitting line, because the residuals are all 0. Finally, let's graph this. We'll just use our same graph here. We'll move axial length over to, oops, we gotta hit this. We'll move the X value to init years, and we'll use refractive errors. And then we need to edit our screen so we can see stuff. Format the axis. We'll hit reset. And we'll come over here, format that. Oops, format this. And reset. Now, when the assumption is that our regression line is linear. You can kind of tell that it's not really all that linear here. Let's get those numbers out of the way. We're going to go to our x-axis. Our x value, our vertical crosses at, let's say, -8. Now we have, so here's our line. This is what our regression line is, our regression equation. Let's actually calculate this line. We can go to Add a Chart Element under our Design tab, add a trend line, a linear trend line, and let's look at our options here. Format the line. We want to display the equation and add the r-squared. So here we go. So this is our format, and we can see that the line fits with an r-squared of 0.75, and there is our slope and intercept, which matches our slope and intercept. We'll just quickly fix our titles. Two years before and after. Come up here. It's a new y-axis. Refractive error. And that's it.